All right. So today we are going to review confidence intervals, which is more than just chapter 8. This is chapters 8 and 10. All right. So talking about confidence intervals, we did not do state plan do conclude. That is an old method that we used to use to structure confidence intervals and significance tests. What do we use? What's our 4 C's? Choose, check, calculate, and conclude. Desk 6, please. All right. A confidence interval is the point estimate plus or minus the margin of error. So when we did confidence intervals, we did both proportions and means. For proportions, the point estimate was p hat. And then we had plus or minus. To calculate the margin of error, we had our critical value, z star, times the square root of p hat times 1 minus p hat over n. This is for proportions. For means, our point estimate was not p hat, our point estimate was x bar. Plus or minus. We did not have z star when we did means, we used t star. Times s over the square root of n, the standard error. This is for means. Critical value, the number of standard deviations away from the mean to capture a certain confidence level. And the critical values that we had were z star and t star. Z star we look at the table for infinite degrees of freedom. For T star, we still look at the table. With n minus 1 degrees of freedom. So another way to think of this, statistic plus or minus the critical value times the standard error. The critical value and the standard error are the margin of error. All right. So then looking a little bit further down the page, We have the p hat plus or minus z star times the square root of. These should be p hats, not p's. Please add the hats on top. Because the whole idea with a confidence interval is we don't know the true value of p. We create a confidence interval so that we can try to estimate the true value of p, but we don't know what p is. That's why we have to use p hat on our standard error. We can use that formula as long as the sample is randomly selected or randomly assigned. We meet our large counts condition, n times p is greater than or equal to 10, n times 1 minus p is greater than or equal to 10. We meet our 10% condition. If those three criteria, those three conditions are met, then we can do our confidence interval formula. And we do have a shortcut on the calculator. You do stat tests, and then we want the one prop z int, which should be choice A on there. If you look, that's what that A is standing for. Should be option A, so it's going to be down below option 9 and below option 0. X bar plus or minus t star times the standard error of x, or sorry, standard deviation of x over the square root of n, as long as the same conditions need to be met, randomly selected or randomly assigned. Instead of large counts, we have large sample condition. The population is normal, or central limit theorem. It is not enough to just say we are less than or equal to 30, or sorry, greater than or equal to 30 on our sample size. You also have to state why that means it would be approximately normal. So you do have to reference the central limit theorem or the CLT. Or the sample distribution is not strongly skewed and it is without outliers. You have to show a graph. And we also have our 10% condition here. This is when we are sampling without replacement. When do we not have to worry about the 10% condition? Random assignment, yes. Not used for random assignment. Because with random assignment, we are not sampling without replacement. And so we do not have to check our 10% condition. If it is randomly selected, and the selection means that it can't be picked again, that's when we have to check our 10% condition, which is most of the time. We do have a shortcut here as well. Stat tests option number 8 is the T interval. Notice they run it together as almost one word, capital T, and then interval is all lowercase right next to it. So for proportions, one prop z int, and for means, we have the T interval. As the confidence level increases, the confidence interval gets larger. You need a larger target to be more confident. Confidence level increases, interval gets larger. All right. And then we have our interpretations. When we interpret the confidence interval, we are blank % confident that the true, whatever our parameter is, will be between A and B. Don't forget, you're going to have to define your parameter. Let's make a note of that. in the choose step. Remember, don't just write down parameter and then out in words you have to state what the actual parameter is. Is the parameter p, because we're talking about proportions? Is the parameter mu, because we're talking about means? Is the parameter beta, because we're talking about slopes? So p is for proportions. Mu is for means. Beta is for slopes. Interpreting our confidence level, if we were to take many samples the same size and calculate a confidence interval for each one, about blank % of them will capture the true parameter, whatever that parameter happens to be in our context. For interval A, B, so this is when we are given an interval. The point estimate is equal to A plus B cut in half. Again, this is when given the interval. If we are not given the interval, then we have to use our statistic as the point estimate. When they give us the interval, they're not telling us the statistic. We're supposed to use the interval to reverse engineer what the statistic is. The margin of error is B minus A cut in half. So to find the point estimate, we add the endpoints together and then cut it in half because we're trying to find the middle. For the margin of error, we want the distance from the center to one of the edges. So we subtract larger minus smaller endpoints. That gives us the length of the interval on a number line. And then we cut that in half so that our length is going from the halfway point to one of the endpoints. Then I want to look at this. I want to focus on this right here. To receive full credit for a confidence interval, this is not in your yellow packet. So you are welcome to jot down notes if you want to, but this is not one of the things that's included in your yellow packet. To receive full credit for a confidence interval, you have to correctly identify the type of interval. So is this a one sample confidence interval for means? Is this a one sample confidence interval for proportions? So one sample T interval for mu or one sample Z interval for P. Yes. You can jot on it if you want to. So when this packet was put together, it was a previous iteration of the same book that we use, and they kind of changed some of the chapters around. So I'm going to be loosely following the yellow packet, but not strictly following it from here on out. So if you need some extra space, you are welcome to jot it down in anywhere that you have extra space. You need to write and check all conditions for that interval. You need to correctly calculate the interval. Make sure you show work. What are you substituting in? Even if you use the calculator to actually find the interval, you want to show plugging into the formula the numbers from the problem. correctly interpreting the interval in terms of the problem, and you may also be required to correctly interpret the confidence level. All confidence intervals have the same assumptions of the corresponding hypothesis tests. All right. Let's try a free response question. You guys are welcome to grab a whiteboard or scratch paper as you have it. Come up and grab a whiteboard if you need one, along with a marker and an eraser. All right. This comes from the 2022 AP Stats test. This was question number 4 on the 2022 test. A survey conducted by a national research center asked a random sample of 920 teenagers in the United States how often they use a video streaming service. From the sample, 59% answered that they use a video streaming service every day. Construct and interpret a 95% confidence interval for the proportion of all teenagers in the United States who would respond that they use a video streaming service every day. And then part B, based on the confidence interval in part A, do the sample data provide convincing statistical evidence that the proportion of all teenagers in the United States who would respond that they use a video streaming service every day is not 0.5. Justify your answer. I will give you guys, let's see how we do with 7 minutes, and then we'll check back in. Make sure to do all 4 C's as you construct your confidence interval. You guys still need another minute or two? Okay, I'll give you a couple more minutes. do want to start going through this because I want to make sure that we have enough time to get to the rest of what we're going to cover today. So this question on the AP exam was graded in 4 sections. The first 3 sections all went with Part A, and then the 4th section went with Part B. So Section 1, the appropriate procedure is a 1-sample Z interval for the proportion of all teenagers in the United States who respond that they use a video streaming service every day. So things that you would have to have in order to meet this, you need 1 proportion, or you could call that 1 sample, Z interval for P. And then you would need to define P as the true proportion of teens in the US who would respond they use a video streaming service every day. So those are the 2 things that you needed to have. Identifies the appropriate procedure as a 1-sample Z interval by name or formula or by the calculations of the correct confidence interval endpoint values. And then you need to state that the parameter of interest is the population proportion. So these 2 pieces would get you full credit on Section 1. Section 2 is where you do the check and the calculate. You had to make note that a random sample was selected. 920 is less than 10% of all teenagers in the United States. Verify that there's at least 10 successes and failures by doing n times p hat and n times 1 minus p hat. And then you have to give the correct interval that corresponds to the test that you named in the first part. So the interval that they have is 0.5588 to 0.622. Make sure when you are doing an interval, it's always the smaller number first and then the larger number. I do not know, I can guess, but I do not know if you flip it around the other way and you report the smaller number and then the larger number, I don't believe that would get full credit. I think that they would be looking very specifically for, did you give the lower endpoint first and the higher endpoint second? If you flip it around the other way, mathematically what you're saying doesn't make sense. So I don't think that they would give full credit for that particular piece. All right, before we go and look at the 3rd section, which would be the conclusion here, I do want to show you how you can get the graphing calculator to give you this interval. So in case you do not calculate something correctly by hand, you can still get full points here. So on the graphing calculator, you go to Stat, you're going to arrow over to Tests, and then we want the one that says 1 prop Z int. Right down here, 1 prop Z int. When I hit enter, it wants X, N, and the confidence level. X would be the numerator of the fraction that was used to find the percent. They gave us a percent here, so we're going to have to change that back into a number of people instead of a percentage. When you put it in the calculator, you need how many people gave that response over N, and N is the second number that you report. Now, something that I learned, because if you do 0.59 times 920, you don't get a whole number. And that's pretty typical when you're working, starting from a percent and trying to figure out how many people that would be. You have to round to the closest whole number. So go ahead and do, what is 59% of 920? $542.8. So we're going to go 543. We'll round it up. So I'd put in 543 here. N is 920. We're using a 95% confidence level, but you'll change the confidence level here to whatever you need based on your problem. And then you go to calculate. There's that 0.558 to 0.622. There's the confidence interval that was given. And it tells you the p hat here, 0.59. You can use that to check. If you had to take it from a percent and figure out a number of people from that, you can use that to double check that you did that part correctly. You do not have to use the calculator for a confidence interval, but you can. There's absolutely no penalties for using the calculator to do the calculation part. Just make sure that you write down all of your work. You have to show work for what you would be plugging into the formula, and then you can write down the interval. I don't have to see all the simplifying steps in between, and neither does the reader. Section 3 was conclude. We can be 95% confident that the proportion of all teenagers in the United States who would respond that they use a streaming service every day is between 0.558 and 0.622. Two things that you have to be looking for on this. You have to indicate that 95% confidence and interpret the interval using words such as we are 95% confident or with 95% confidence. And you have to provide the interval endpoint values. And then you have to talk about the population proportion in context. And then part B was section 4. 95% confidence interval is 0.558 to 0.622. So that indicates that between 55.8% and 62.2%, those are plausible values for the proportion. Is 0.5 contained inside that interval? No. So how are we going to answer part B then? Is 0.5 a plausible value? No. There were two criteria that we were looking for there. Those two criteria provides a correct conclusion. There is convincing evidence or there is not convincing evidence. So you have to make a decision. Yes, there is convincing evidence, or no, there's not convincing evidence. And you have to provide the correct justification based on whether the value of 0.5 is contained in the interval on part A. All right. Let's jump back to your yellow packet for a minute. I'm going to talk about chapters 9 and 11. This was hypothesis testing. Once again, with hypothesis testing, we want to follow the 4 C's. Choose, check, calculate, and conclude. The null hypothesis, H, and then it's not written like that. It's written with a little o next to it. And this is the claim we are assessing. So the claimed value for P, mu, or beta. The alternative hypothesis, what we feel might be true. P-value, assuming the HO is true, this is the probability of obtaining a sample statistic, P hat or X bar or B, as extreme as the one in our sample, as extreme or more. As the one in our sample. If the P is low, reject the HO. If the P is lower than what? If the P is lower than what? A lot of times it's going to be 0.05. It's whatever the alpha level was. I have not seen an AP exam FRQ where you're expected to do this, where they do not tell you what level you should be using for alpha. Every single one I've ever seen, they tell you what you should be using for alpha. If the p-value is less than alpha, we reject the HO. There's convincing evidence that the HA is true. So if we reject, then we have convincing evidence. And if we fail to reject, then there is not convincing evidence. And then when we did hypothesis testing is also where we talked about types of errors. We had type 1 error and type 2 error. Type 1 error, we reject the null when we should not. With a type 2 error, we fail to reject when we should have. The power is the probability of correctly rejecting the null hypothesis. When we are looking at proportions, the HO, the probability that P is equal to some value, they're calling that P naught, versus the HA, P could be less than that or P could be more than that. It doesn't have to strictly be smaller. We have to meet our conditions. We need random selection or random assignment. We need our large counts condition. N times P is greater than or equal to 10. N times 1 minus P is greater than or equal to 10. So 10 successes, 10 failures. And then our 10% condition. But again, not for random assignment. Z gives us our test statistic, or you can use the calculator shortcut. Stat tests, option 5, 1 prop z-test. There are often multiple choice questions that rely on you knowing how to calculate the z-score because it'll ask how many standard deviations away something is. It might not use that exact wording, but that's what they're after. In that case, you would have to calculate the z-score in order to answer that part of the question. And then for means, the null hypothesis, mu is equal to mu null versus mu is less than or greater than or not equal to. We should add those in here. Could be less than, could be greater than, or it could just be not equal to. Less than, greater than, or not equal to, as long as the following conditions are met. Again, randomly selected or randomly assigned. We have to meet our large sample condition. So either the population is normal, we can use the central limit theorem, or the sample distribution is not strongly skewed and does not have outliers. You have to show a graph in that case. And then our 10% condition, but not for random assignment. The test statistic this time is t. We calculate it the same way as we calculate z. It's going to be value minus parameter over standard error. So for both of these, value minus parameter over standard error. And we do have a calculator shortcut for this as well. Stat tests, option number 2 for a t-test. We reject when the HO is less than alpha. We fail to reject when the HO is greater than alpha. And then we have interpretations. Interpreting our p-value, that would be assuming the null is true. There is a p-value probability of getting the observed result, or less than, greater than, more extreme, purely by chance. That is always part of our conclusion. You need to be interpreting the p-value in context as part of your conclusion. When you conclude for a significance test, because the p-value is greater than, less than, alpha, we either reject or fail to reject the null. We do or do not have convincing evidence for the HA. It is always the HA that we are looking for convincing evidence for. Remember, we never find, and we're not looking for convincing evidence for the HO. The HO is just assumed to be true. You're trying to find evidence that it's not true. Type 1 errors. The null hypothesis context is true, but we find convincing evidence for the HA. Type 2 error. The HA is true, but we don't find convincing evidence for it. And then interpreting power. If the HA in context is true at a specific value, there is a power probability that the significance test will correctly reject the null. I would highly recommend looking at these interpretations before we get to the mock exam next week, looking at how you interpret. So the yellow packet, anywhere it talks about those interpretations, I would be looking at those a little closely. This is the same screen as before, but now I want to look up here. All tests assume a simple random sample from the populations being studied. All tests are testing to see if the sample has enough evidence to claim that the populations involved meet the criteria of the problem. All right. Let's look at another free response question. There we go. This is from 2021. we only have 3 minutes until the bell, so I'm going to run through the answer. This was again graded in 4 sections, with part A being sections 1, 2, and 3, and part B being section 4. You needed to define the parameter P. The null hypothesis is that P is equal to 0.40. The alternative is that P is greater than 0.40. And an appropriate test would be a one sample z-test or a one proportion z-test for P. You needed to correctly state the equality for the null hypothesis, correctly state the direction for the one-sided alternative hypothesis, provide sufficient context for the parameter, and correctly identify the test. Check and calculate made up section 2. And just like with the interval, we can do a test. So you would go to stat, arrow over to tests. We want the one prop z-test, number 5 right here. The null hypothesis was 0.4. The x value, this was the, 38 people? I want to say it was 38 out of 90. 38 people that ordered out of 90. Our null hypothesis was that we were greater than 0.40. Or sorry, not our null, our alternative hypothesis is that it was greater than 0.40. And then we can go to calculate. It gives us the z statistic. It gives us the p-value. And then we have our p-hat and our n value. So you can use that to calculate. Section 3 was the conclusion. Because the p-value is greater than 0.05, the null hypothesis should not be rejected. And then because failure to reject the null hypothesis was decided in part A, it could have been a type 2 error. Tomorrow we'll talk about 2 sample hypothesis tests, and we will talk about the stuff that we did in chapter 12 to round off our review.